I want to know the name of the fucking attribute. They absolutely need the name of the attribute. And of course, I'm looking at this documentation that Toon Boom has here, and they don't have the definition of what the hell an attribute wrapper is in their documentation, so I'm not happy about it. So we're going to have to resort to basically searching through all of the documentation for if this thing actually even exists. Damn it. Well, this could be... It's always frustrating when you run into these sorts of things. Attribute has object name. Okay, that's what I was looking for. And it looks like that's not a function, that's just a thing. Well, this isn't just basic info. This is... I mean, I understand why it's not there. It's not there because this is like a C++ class that they're interacting with. So like the documentation, they used a generator for the documentation. Pretty obviously. And to include the C++ code in that document is probably very difficult. The attribute name is just fucking attribute. They're all just attribute. I mean, this is the other thing, is some of it's just broken. Yeah, that didn't work very well at all. So if we looked at the adders inside of the actual camera peg, like you'd think basically we'd have, and this looks like 30 of them. I mean, if we were going to grab these by name, we would basically be saying like attributes like node get attribute by name. Saying get the position. So let's see if we can actually get any of this. Well, let's see if the pos2d value is even here. So all pos2d value equals position adder dot so they've got some really weird wrapping for the variables. Expression attribute undefined is not an object. This is just typical bullshit with very poorly designed APIs. Will be just like you can't figure out what something is. So like I'm calling attribute dot pos2d value, and then it just like it crashes inside of it, and there's no way to tell if it's a position 2d value. So let's see, like message log dot trace. Let's just do like the. Oh, I guess I need to do the position attribute. All right, maybe that'll actually work. Okay, so it's a type error right here, so and this is just the really ugly, awful way of discovering types and stuff inside of JavaScript. So this has x, y, around, 2 vector 2D, distance, add, interpolate. So we have x and y for position 2D, and it's also got some other stuff. So we'd be able to do something like position 2D is like that, and I assume that we've got like this position 3D is going to be x, y, and z. Let's see if we can actually fetch it. Alright, so we had negative 11.1 and negative 10. So it looks like these like 2 strings and all that stuff is just a nice convenience method. So this camera peg does actually have those coordinates. Okay, so we can actually get the position of the camera. All right, good. We can do that. That's very fortunate. All right, can we get the position of the master camera? So what we want to do is we want to get the position of the camera. See, we don't know what these things are actually called, so we're actually discovering that. So we want the 3D value of the position of the camera, and we'll go ahead and print that out. And the other thing that's on the camera is we're going to look for name equals master camera. We're looking for the position of this guy, but we also need the FOV. So we've got like position, which it's got an offset. That's the problem, is I don't know if this is an actual offset value or if this is a position value. And then we got FOV. So what we're gonna do is we're gonna going to do the var offset value equals, actually offset attribute, node.get attribute offset, and we're going to get another 3D value. Actually, I'll just copy paste this crap because I can. Pause 3D, so offset 3D value. Master camera offset. And we're also going to grab the FOV, so we want FOV adder equals node get adder camera node FOV, and I think it's probably a double value. Maybe I should spell value right. Alright, so let's see if we can actually snag that information. Found the camera. The camera position is 0, the camera offset is 0, and the camera FOV is 0. Obviously that's not correct. And that's because we weren't passing in the right thing for the attribute, it looks like. Alright, so we actually got it. We found the camera. The camera is, yeah, and again, as I expected, this sort of bullshit is happening where the found master camera and then the camera position is 0, but the camera offset is 0, 0, 12, which is just amazing when you think about it. That we're storing position as position sometimes and offset other times. Like it's it's where it is. Why you gotta be hating all the time? We do have the FOV, which is good. So we need to actually compute the final position of the object. I thought you said Thigh Master. No. No, I did not, but I have now. Alright. So basically what we're going to be able to do is we need to calculate a width and a height. We're going to need the aspect ratio again for this sort of thing. Well, let's take a look here at this thing. So if our camera is at 0 in the depth, the z-axis, which is, alright, I need to write that down. Z-axis is depth. The distance here would be 0. And if this was a 0, or this was a 6, this is a 12. So master camera peg is an offset from this master camera. So it's really going to be like, the distance is going to be literally just the camera peg position is going to be the distance to the frustum. And then the field of view, so we need a height scalar, we need a width scalar, so let's see, tangent in JavaScript, how do we call that? Use math.tan. Alright, it's math.tan, and accepts radians, but it's often easier to work with degrees. The following. Alright. So we have degrees to radians. So we have the width and the height scalar for the thing. Like we'll have the, I guess, the scene width, and the, I guess this will be scene height, and this will be scene width. And we're going to need the translation amount, so we're going to need the amount of movement relative to this thing. So we need to know how far to move it. Is that just going to be the... So if this is our frustum, this is our camera, we're looking here, and our FOV to our height is going to look like this, and our translation is going to be if we move this down, it's still looking straight forward. So our translation is just literally our X and Y values. we aren't supporting camera rotation. We don't have to. Alright, so what we're going to do is we're going to need the Now, I think this master camera is actually a bit of a problem. Like, the master camera position is looking at 0. So it's at 12 front, so it's positive 12Z. And then this camera peg is actually moving forward, so it's like -6 to zoom in, so it's actually at 6. So it's going to be, the distance is actually going to be from 0 to the camera peg position. The camera peg position is off of the master camera, so we actually have to, the distance is going to be, RZ is going to be the master camera Z plus the camera peg Z. And then our distance is going to be our pause dot Z. Well, alright. So let's break this up. So we're going to need a bar camera position. That's going to equal a new object and have like X. Is that even valid? I always forget. I work in so many different languages that I just forget all sorts of shit all the time. Yeah, it's totally valid. Alright, cool. Alright, so what we're going to do is we're going to discover all these different things. So we're going to grab the master camera and we're going to grab the master camera peg. And we're going to combine those together. So this will be master camera, this will be master camera peg. so if master camera does not equal null and master camera peg does not equal null, then we'll discover the camera position. We also need the camera translation. Well, we already have the camera translation that's in the camera position. But we do need the camera FOV. That'll be 0. Alright, so if master camera does not equal that, then we want to grab the position and the offset. So I'm going to write a function that will actually grab me a position of a thing. And basically what we want to do is we want to do var pos3d equals position dot pos3d value var offset 3d equals offset dot pos3d value, and we're going to say var pos equals new xyz thing. And this is so we don't have to work with Qt units and objects. We can actually just work with things that exist for us. So we'll get the position of the node based on that. Alright, so it's basically going to be master camera position equals get position of node master camera, and camera peg position is going to be get position of node master camera peg. And then we'll also want like get and the camera FOV is going to be like node get adder master camera, and then we're going to get the FOV, and then we'll just do dot double value, because I guess we could kind of do some of this where maybe it won't be null on us and screw us all up. We can only hope. Alright, so the camera position dot x equals master camera position dot x plus camera peg position dot x So it gives the camera position, And then we want the camera FOV. Alright, so then we want to get the size of the scene width and scene height. And we're going to need our scene aspect. So we've got the aspect ratio there. And this is going to be the distance is going to be our camera Z. So our camera distance equals camera position.z, and our scene height is going to be but we already did this just a little while ago in C++ land. Yeah, that was just our camera height and fmath and all that stuff. And we had to multiply by the aspect ratio there to get the distance. And degree to radians is going to be right here. Let's get the aspect and message log.trace the we should say projection height and projection width. And that's going to be gosh, height. So let's see if we've coded that out anywhere near worthwhile. 442. That is It's pissed because I put an F for float, because JavaScript doesn't have Fs. Can't find variable master camera node. Yeah, here it is. Can't find variable FOV. Camera position is -11.16. Camera FOV is that. The camera position should be 12 back, 12 forward, and then 6 back. So it should be at 6. That reminds me, the camera distance should be the absolute value of the Z. Okay. We'll be here when you get back. Probably. So let's see, the projection width is, the aspect ratio is 1. Well, that is true, the aspect ratio is 1. Camera distance is 6, so the projection is 4.5 by 4.5. Is that true? So if the scene is 24 by 24, this is saying our projection is 9 by 9. And why is that? Like, our width and height is 24 by 24. I mean, our camera distance is 6. Our camera FOV is 41. So let's just do this. Our tangent should be 87. Alright, so our tangent equals 0.87. Our distance equals, let's just say 12. We'll just say, our distance is 12 because we're the standard camera. So our scene width should be 2.0f times the distance multiplied by the tangent of FOV. So this will be FOV times 0.5 times degrees to radians. So we need half of the FOV, so tangent is going to be of so it's going to be 0.373. So it's going to be 2.0 times the distance times 0.373. And we know the answer is supposed to be 24. So that's the actual number of units wide that our scene is. And of course, if we do our calculator right here, it's 2.0, so it's going to be 12 times 2 times 0.373, which is 8.95. Is like the width and height of this thing, supposedly. Which is obviously wrong in terms of that. So I mean, this is where harmony and math don't really add up. There's did I hit a key here? That's funny. I was hitting keys like the plus button and the minus button. And I had mapped those to things. Like, yeah. I mapped those to things because I was playing Pharaoh, and I needed to map something to the keys to like do stuff, something I wasn't mapped to something else in the game, because once you like Alt Tab out of that game, like everything goes to hell. So I had to like make a custom screen capture thing for it and do a whole bunch of bullshit. Now when I'm doing math, it fucks up all this stuff. Maybe I should change those hotkeys real quick here. Change them to so I have to do Control plus and minus. Alright, fun times with overlays. So we'll get all that sorted out so that won't screw up my stuff in the future. So basically, we've got this magic value here, which turns this computation into the actual thing. There's like some scaling value, and I hope to Jesus that this is consistent. Otherwise, we're going to have some major effing problems. So our scale, we have a constant here which is being multiplied out, which looks like it's basically our actual units is going to be 24, so we need something that takes 8.95 and equals 24, and that's going to be this 0.373. But it's actually, we need to do the other way around. We're actually going to need to this is going to be so we need to take our computed units divided by our actual scene units to figure out what the fuck our thing is going to be. So we're going to have like our var x x fix and our var y fix. And that's going to translate from camera space units into world space units, and this is going to be basically our scene units x. It's gonna be, oh, this is so shitty, but basically it's going to be our normal height and our normal width. And the camera distance is going to be this like master camera position. Var is like normal camera position equals master camera position dot z, normal camera depth. So it's going to be our normal width divided by our scene width, and we're going to have to do the same thing with this y. And our projection width and height need to be divided by this thing. Well, I guess we can just do the opposite. We can just do like and what we should get right here is that our projection is 24 by 24. And we're getting that our projection is 24 by 24. Okay, good. So we have fixed our projection width and height. And so what we're going to do is we're going to move our camera in. So -6. And our camera projection is 24 by 12? Wait, what? Alright, let's see if that fixes it. Our camera is 12 by 12, so this would be halfway to the object we would expect it to be. Would we expect it to be this way? We are half the distance to the camera. We'd expect everything to be twice as big? Well, I mean, if we're using an orthographic camera, then yeah, it would, right? Because we're... No, that's not true. If it's an orthographic camera, it doesn't matter how far away we are. Half the distance, things should be twice as big? Is that twice as big? It looks like it's... Looks like it might just be twice as big from the center. And so if we do 3, like -3, right? I mean, -9. What would we expect it to be? This thing is saying it's 6 by 6 is this canvas area. Two by 2. So if this was 2 by 2, I mean, it looks like it might be correct. It's at least close to correct. So that's something. So what we want to do next